Mr. Smith invested $2,500, so his starting investment, which is a key number in these kind of problems, is $2,500. And he earns 3% interest compounded annually. So that means each year he gets 3% on top of what he had before. So our growth, right, because the value of the money is growing, it's called the growth factor, is equal to what? Well, really, what you can do quickly to do this is you take 1 and add the decimal of your percent. So 0.03 is 3%, and your growth factor is 1.03. So what is happening here is you're getting this number because when you add 3% to what you originally have, you're adding 3% to 1 or 100%. In other words, you get 103% of what you started with, and you can calculate this with a simple value to convince yourself that this is true. If you have $100 and I say add 3% to that, you would add $3, right? 3% of 100 is $3, but put this together and you have 103. So originally you had 100, now you have 103, or 103 is representing 103 out of 100, or 103%. And that's all that's going on right here. So to calculate this, right, you're going to multiply by 1.03 over and over again each year. So here, if we're looking, I think they're asking for 4 years. Yes, you do 2,500 times 1.03 the first year. You would get a number. Multiply that by 1.03. Multiply that by 1.03, and multiply that by 1.03. And obviously this would be really annoying if you do it 100 times. But the quick way is just to go 2,500 times 1.03 to the power of years, or the power will equal the number of years or periods at which your interest is compounding. So if it's compounding every year and 4 years are passing, it's compounding 4 times, or to the 4th power. And you can model this quickly on the graphing calculator with 2,500 times 1.03 to the 4th power, and that you would have $2,813.77, but they want the formula, right? And here they're representing the formula choice 2. It's 2,500 times 1 plus 0.3, which is 1.03 to the 4th power. Okay. Here, Shauna buys a new bicycle, and the starting value, which is always a key here, equals $259.99. And she knows that next week will be off 30%. So the sale is equal to 30% off, not of, but off of the original. So that means if you have $259.99, right, you take 30% of that, right, or 0.3 times that, and subtract it from the original amount. So it's $259.99 minus this number. And a quick way to do that is to think, oh, if you lose, if your new price is 30% of your original, the remaining amount must be 70% of what you started with. Think of something simple like $100. If I said there's a 30% sale, you would subtract $30, right? And what would remain? Well, you would pay $70. So your finishing price is always going to be 70% of the 100. So instead of subtracting like this, we can just combine these steps by doing 259.99 times 0.7, or 70%. But then they say the tax rate is 7%. So we're going to add 7% to this amount, right? So how do you add 7%? Well, think back to 100. If you have $100 and you add 7%, you would add 7, right? And the new amount would be 107. So when you add 7%, your new value is 107% of your original, right? So that's kind of the reverse of the problem of this example here. When you lost $30, you have 70% of your original value. When you gain 7, you have 107% of your original value. So that means we can multiply this, right, by 1.07, which represents 107%. So we have these two steps, 1.07, we can multiply and group it any way. Remember, multiplication is commutative, it can be reversed, and associative, it can be grouped in any way, times 259.99. Press enter, and what happened? Well, that's our sale price, 194.73251, and they want us this to the nearest cent. So 194.73. So $194.73. All right, thank you.